Today we're going to be looking at systems of inequalities with the application piece. Application, I know for some of you, Miss Golly, just call them what they are. They're word problems in our brain. Okay, we can call them word problems. And I'm going to go through two of these with you today. I want to go through two of them with you today because there's just a couple different types, if you will. I want to take a look at number one. It says in basketball, you score 2 points for a field goal and 1 point for a free throw. So in case you're not familiar with basketball, it's the breakdown there. We're not worried about three-pointers. We're not going to worry about the three-pointers because then that adds a whole extra variable in there. So you're not going to shoot any three-pointers. You're sticking with the 2-point field goals and the 1-point free throws. Suppose that you have scored at least 4 points in every game and have a season-high score of at most 14 points in one game. How many field goals and how many free throws could you have made in any one game? What are some of the key phrases that are going to tell us that these should be inequalities and not just plain old equations? At most. Right there. So at most is going to tell us. There's one other phrase in there it's going to tell me. It was before at most. At least. So at most and at least. Now if it said you scored exactly 4 points or you scored exactly, then we're talking equations. And then also we're looking at how many field goals and free throws could you have made in any one game. So meaning that there's going to be a variety of possibilities for you for scoring those points. So let's start with letter A. It says define your variables. When you see that phrase, what I'm wanting from you is, if you're using X and Y, tell me what X is representing and tell me what Y is representing. And since they're inequalities, since we had at least and at most in there, we know they're inequalities, we need to make sure we're going to graph for our solutions. So oftentimes, for most of us, it's easiest if we just use X and Y since we're going to be graphing. So I'm going to stick with X and Y. If you want to choose other things when you try these on your own, you can use whatever variables you want. But since we're graphing, most of you end up changing them to X and Y anyway to graph. So I'm going to have X be the first thing that's listed. It says how many field goals. So we're going to go number of field goals. And I'm going to have Y be the second thing that's listed, and it's going to be number of free throws. Remember, we want to be very specific when we define our variables. Is it how many points a field goal is worth, or is it how many you're going to make? So be specific on those. So when it says define your variables, I want to get you guys used to that phrasing because that's how you're going to hear things phrased. Define your variables means, hey, just tell me what they mean. That's all we're going for. All right, now we've got to pick apart our problem, and it says to write a system of two inequalities, system of two. So let's look for some of our totals in there. Suppose you've scored at least 4 points in every game. Well, in order to get those 4 points, there's 2 points for every field goal, 2 points per field goal, plus, and if you want to put the 1, you can. The 1 might just help us remember, hey, this is for my free throws. There's 1 point per free throw. And then it says you score at least 4 points. Most of you on your quiz did a great job with which way that inequality symbol is supposed to be facing. If it's at least 4, is 4 the most or is 4 the least? 4 is the least. So which way are we going to open? Towards the X and Y or towards the 4?
Towards the 4.
You guys told me that 4 was the least. If 4 is the least, our symbol is going to open the other way. You guys all told me 4 was the least, and that was perfect. So it's going to face the other way. So the one total we're given, we have at least 4 points. We have that taken care of. And then it says you have a season high score of at most 14 points. So again, to get that total of 14 points, it's still 2 points per field goal, 1 point per free throw. And then it says we have at most 14. So is it going to open towards the X and Y or open towards the 14? 14, because 14 is the most. And we can have 14. That's okay. It's at most 14. So we can have 14. So this problem, this is one I definitely want to go through with you guys because it's kind of a new look for us that the left-hand side is the exact same for both. A 2x plus 1y is the same for both of those, and that's okay. Remember, these are inequalities. I know some of you might be thinking, Miss Callie, if we did like some elimination on this, x and y would be gone. You're right, they would be. So good thing we don't have equations. Good thing we're looking for some shading on our graph. We're looking for where the shadings overlap, not just one point where they might intersect. All right, so that's asking us to graph. X and y are on the same side of the inequality symbol. So do we have slope intercept or standard? We have standard. So when we think standard form, I know I always draw this little chart. Some of you don't draw the little chart, but when I draw it, you're like, oh yeah, that zero thing. Yep, that zero thing where we find our intercepts, exactly that zero thing. And if you need to, guys, don't be afraid to write things off to the side and split them apart so you're not just staring at both of them together. I know sometimes we just look at the wrong inequality, we end up graphing things wrong, not because we don't know how to graph it, but because we look back and forth between the two, and sometimes we get the wrong number. So if we put a 0 in for x, what's our y going to be? 4, yeah, y is going to be 4. And then if we put a 0 in for y, x is going to be 2. All right, and again, show as much work as you need to on those. I know most of you have just gotten the habit of kind of covering up whichever one you're putting the 0 in for, and that works just fine. If you need to write out the work, actually writing the zeros in there, then you stick with what works for you. We've graphed a whole bunch in standard form, so you do what works for you at this point. All of you can graph in standard form. I know you can. All right, so when we go to graph, what do I have to make sure I do on my axes before I start graphing points? Label. Yes, label. So on the x-axis, I'm going to go back up here, and it says x is number of field goals. So the x-axis, I want to label as field goals, and the y-axis we want to put as free throws. Whatever you label your variables to be, your axes just match it. So if you're like, Miss Guy, how do I know to put field goals down on the x-axis? That's what we said x was. That's why it's so important you label your variables, you define them right away. Now, if you're just going to keep your scale going by ones, you don't have to. I'm not going to make you guys try to cram all those numbers in there. If you want to label, you can. Since the boxes are so close, let me just make a suggestion, and I'm going to do this. I'm going to do one more problem with you guys today. What I like to do, even if I'm going by ones, since they're so close together, I'm going to label 1. I'm not going to label 2, and then I'm going to label 3. So I'm still going by ones, but I'm just labeling every other line because otherwise the boxes are small and the numbers get so crammed it's really hard to read them. So I'm going to label every other one. So my scale is not going by 2s. My scale is not going by 2s. I'm just labeling every other line. So it kind of looks like I'm going by 2s, but I'm not. Just want to give you that suggestion. Some of you write kind of big too, so you're not trying to cram everything on there. So I can do the same thing going up the y-axis. Again, my scale is not going by 2s. I'm just labeling every other line just for spacing. And that's an okay thing to do. That's a great thing to do. All right, so our first one up, we have y is 4. I'm going to go ahead and get this line graphed, and our x is 2. We have that equal to sign there, so we're going to have a solid line. There we go. Need to try to get a straight edge that works on here. Here we go. Now before we graph the other one, and this is the thing I was trying to get a point across last class. Some of you were struggling to graph these last class, even though last week you did a great job graphing them one at a time. Graph them one at a time. Let's do the shading for this one before we even find intercepts or anything else for that other inequality. Easiest point in the world to test.
0, 0.
0, 0. So let's test her. And we also refreshed last class on what it meant to test that ordered pair. I don't change anything about that inequality except I replace the variables with zeros. Nothing else changes. Some of you were trying to put a 0 like next to the 4 up there and trying to leave y and doing some crazy things. Replace the variables with zeros. What's going to happen to this entire left side? We're just going to have 0. All right, so moment of truth. Is 0 greater than or equal to 4? No. So am I going to shade the bottom of the line or the top? Top. Now when we shade, we know we have another one to shade. So I'm just going to go nice and light. I'm just going to go nice and light on my shading because I know I'm going to have a second one to graph. I know I have a second one to graph, so I'm going to go nice and light on the shading. So let's go ahead and graph that second one. If you have a second color, I just switched mine to red. I think it's much easier if you use a second color. But that's up to you. So we have 2x plus 1y is less than or equal to 14. X and y are on the same side. So if I put a 0 in for x, this time my y, if I put a 0 in for x, my y is going to be left with 14. If I put a 0 in for y, now I have to do 14 divided by 2. Remember, we always divide by what's in front of the variable. Even if it means we get some kind of ugly fraction to deal with or a decimal, that's okay. We have to divide by what's in front of the variable, and we get a 7. Now my crossing these out up here is similar to you just covering them up with your finger. And I know that's what a lot of you do. So when we go to graph, we have y at 14. Oop, I didn't label that high. There we go. There's y at 14. And the x is at 7. We have an equal to, so we're going to go solid line. Oops. All right, easy point to test. Let's put our zeros in. Unless our line goes through 0, 0, that doesn't happen often. If it goes through 0, 0, we have to pick something else. If I put zeros in for my x and y, that entire left side, it's just going to be 0 again. Now this time we have 0. Is it less than or equal to 14? Yes, it is. So are we going to shade the bottom side or the top? The bottom. All right, so we shade the bottom. So now we have to decide. Now we have to decide where we're going to shade. This is why I like to graph these one at a time. Some of you last class were trying to graph both lines, and then you were staring at my answer. You're like, Miss Golly, how did you get the dark region up there? Shade them one at a time, and especially if you use two different colors, it's really easy to see. We need where the two shadings intersect. So for me, if I use two different colors, I just look at where the red and purple are. If I look below my purple line, all I have there is red. If I look above my red line, all I have is purple. If I look between the two lines, that's where my red and purple are together. So that's what I want to shade. If you have a highlighter or you have a third color, great. I didn't have a third color to give you. Or just shade in nice and dark with either your pencil or if you used one of my red pencils or whatever you have. So again, we're looking for where the shadings overlap. Now I know when I put my answer key up for the worksheet last class, I just had the final answer shaded in. And that's what we're going for. And if you can get to the point where you don't have to shade them both and you can look at them and tell, that's great. But that takes a lot of practice. So for us, do like we did here, graph them one at a time. Because I know based on your quizzes, you guys can graph these. If I give you a single inequality, you can graph them perfectly. So graph them as singles and then decide where the shadings overlap and find your final answer for the system. All right, now, one of the most important pieces is letter C. We want the solution. We talked about this quite a bit the last few classes. Where do I find my solutions up here? Where are they at? Yeah, in the yellow part, in that final answer piece where the two shadings overlapped. And when you find a solution, you can use any ordered pair you want in there. It doesn't matter. I know for some of you, when you've looked at my answer keys or if I've helped you with problems, you're like, Miss Golly, how did you know to pick? For example, I'm going to pick 3, 6. Miss Golly, how'd you know to pick 3, 6? Why did you pick that one? I picked it because, in this case, it's in the yellow shaded. It's in my final solution area. You can pick any ordered pair you want in there. I just happened to grab 3, 6. You could pick any ordered pair you want in there at all. I mean, we could pick 3, 0. We could pick 3, 1, 3, 2. We could pick 4, 3. We could pick 5, 2. We can pick any ordered pair in that yellow. I'm not picking any one for any special reason. You just have to pick one, and there's a lot to pick. Now, here's the thing, though. We want to write it in sentence form. I want us to be able to interpret what we're finding. It's great. That's a big step for us. If we're finding the solutions, we know where to find them. We're picking them out. That's awesome. But now, what the heck do they mean? You can look at your labels on the axes to help you. You can look at the labels you put with your variables to help you. The 3 that I have, is that going to be 3 field goals or 3 free throws? 3 field goals. So you could make 3 field goals and 6 free throws. That's what I'm going to be looking for that final answer piece. And that's super important part. That's a super important part. It's great if you can write the system. That's a big part of the battle. I know we can all graph the systems. And I know we're getting much, much better at figuring out where those solutions are. But then now with the application part, a big piece of it is you found your solution. What the heck does it mean? And again, if you do a good job labeling, interpreting that solution won't be so bad for us. Won't be too bad. All right, I promised you guys to do 2 with you today. The second one that I want to do with you is, I want to do question number 5 with you. I want to do question number 5 with you. Now, there are a few questions similar to number 5 before you get to 5, but 5 is one I want to go through for a couple different reasons with you. All right, so number 5, we have the boys and girls soccer clubs are trying to raise money for new uniforms. The boys soccer club is selling cards for $2 a piece. And the girls soccer club is selling candles for $4. They must raise more than $800. The girls expect to sell at least 100 candles. How many cards and candles could they sell and meet their goal? So some of those key phrases, again, that tell me this isn't as simple as I write a couple equations and I find an intersection point, or I write a couple equations and I do some elimination or substitution. Some of those key phrases, more than, we need to raise more than 800, and at least 100 candles. That means there's a wide variety of options. It doesn't say they have to raise exactly $800. It doesn't say they're going to sell exactly 100 candles. We have a more than, we have an at least. So it means there's a lot of different options. There's a lot of dollar amounts that are more than $800. There's a lot of amounts of candle sales that are at least 100. Lots to go on. So let's start at the very beginning. Let's define our variables. Since those key phrases tell us it's going to be inequalities, whenever I have an inequality, I have to graph to find the solutions. We don't have the substitution or elimination option. We've got a graph. So since we're graphing, I like to use X and Y. You can use what you'd like when you do these on your own. A lot of you end up changing them back to X and Y, or you get stuck when you go to graph. Miss Golly, I have a C and a B here. Which one should be my X? Well, if you start with X and Y, you won't have to decide which should be which. So let's have X equal, I'm going to go with whatever is listed first, and it asks how many cards first. So I'm going to go number of cards. And then the second thing listed is what I always make my Y. Number of candles. That's such a super important piece. Because if I define my variables, then I know now, since you know you're going to have to graph, a great idea, guys, might be, once you define your variables, I would go write down and label my axes to match. You guys know I'm all about the labels when we do an application problem. You guys saw that on your quiz. It's going to come up again on your test. I'd like to give points for labels. When you label, you show me you understand what the question is actually asking about, which is awesome. So after you define your variables, why not just go ahead and label your axes and you won't forget. Just label, label. All right, now we have to write our inequalities. Our first total we have, it says they must raise more than $800. So to get $800, we know it's $2 for every card. And we know that it is $4 for every candle. And we're looking at $800. Now I know if I ask you guys for equations, most of you would write this equation, no problem. You'd put your equal sign and move on. But we've got that pesky phrase more than in there. It's facing towards. If I want more than $800, is 800 the most I want, or is it the least I want? If I want more than 800, 800 is the least. So my symbol's going to go the other way. Now, if I want more than 800, I don't want 800 exactly, so there's no equal to. Here's one of the big reasons I chose this question. I told you I chose it for a few reasons. This is reason number one. They're not always going to be equal tos. If I want more than $800, $800 doesn't cut it. $800 and 1 cent cuts it. But I need more than 800, so there's no equal to. Another big reason I chose this question. We have another total we're given. It's 100, and I'm going to label this one. But it's just 100 candles. It doesn't say 100 total items. So this is not, I just take X plus Y and we need to have it more than 100. It's just 100 candles. It's not 100 cards and candles. It's not 100 items. It's just 100 candles. This phrase right here, this is the biggest reason I wanted to go through this specific one with you. And there are a few questions like this one, and I'll help you pick those out here after we finish this one. There are a few questions like this one in the rest of the practice for you. So candles. So I have to look at this very carefully. Candles are my Y. Candles are my Y. And it's just how many I have. The 100 has nothing to do with the money, so I don't want the $4 with it. I just want the number of candles. We saw the phrase at least in our first example today. At least means 100 is the least. So we've got to open the other way. And at least means it could be 100. I know this type is a new idea for us. We're just looking specifically at one of the variables, and it has nothing to do with how much that candle cost. It's purely how many there are. So Y is how many candles I have, and I want more than or equal to 100. So this one right here, this inequality right here, this is the part I want to highlight. This is why I chose this question. So you have to be on the lookout for, if you're just looking at a specific total for one of the items in the problem. This is not candles and cards together, so you really have to slow down. It's not just automatically going to be, oh, X plus Y, and it gets me the 100. This has nothing to do with the cards. Nothing to do with X at all. So when we go to graph, and I've put these little notes, this is reason number 3 I chose this problem. I put a little note there for you of what your scale should go by to get these to fit on your graph. Okay, I didn't want you guessing at it. I wanted to make sure it was going to be a nice, easy check for you too if you check it with mine. So it says X and Y scales both by 25s. So let me give you a suggestion, same as with the first problem. My very first tick mark is going to be 25. The next one should be 50, but if I try to squeeze 50 in there, and I can write pretty small, it's going to be so clustered, I'm not going to be able to tell what's what. So I'm not going to label the next one 50. I'm going to go another one over and go 75. Then the next one should be 100, but I'm not going to label it. I'm going to skip, and I'm going to go 125. 150, 175, 200, 225, 250, 275. So, I mean, I'm even having trouble getting it to fit, and I'm just labeling every other one. So if you need to label less than that, you sure can. So label every other one. It's just going to make things fit a little easier. Or as long as you label the first few, so I know what your scale is going by. If your scale is going by something other than ones, I need to see the labels. Otherwise, I assume it's going by ones, then I'm going to think you graphed wrong. So even if you just label the first few.
Is that last one for 25?
Even if you just label the first few, that's fine. As long as I can see what your scale's going by, I'm fine if you just label the first few. All right, so we have our scales labeled. We have our axes already labeled. We have cards and candles. So let's go ahead and graph. Just like the last one, I'm going to graph these one at a time. I'm going to graph these one at a time. I'm going to graph the line. I'm going to shade for that one before I even look at the second one. Again, some of you last class, you were trying to graph both lines and then trying to figure out how I got that darkened area. Shade them one at a time. Shade them one at a time. All right, so here we go. We put a 0 in for X. My Y is going to be 200. Put a 0 in for Y. X is going to be at 400. That's why we had to have our scale go so big. I'm not going to ever give you a graph that has 400 little boxes on it going one way. That'd be a giant graph. So we just change our scale. We can make this graph work for any problem. We just have to adjust our scale. And we haven't really been doing that much. That's why I told you in letter B what you should make your scale go by. We haven't had a lot of practice with that. All right, so my y is at 200. And my x is out at 400. And be careful, guys, this one is not an equal to. So even though it's an application problem, we can still have dotted or dashed, whatever you'd like to call it, lines. That's okay. Put our zeros in. 0, 0 is not on our boundary line, so we can use it to test. That left side again gets us a 0. 0 is not greater than 800, so I got to go the other way. 0 is not greater than 800, so I go the other way. And again, just make that shading, guys, nice and light. Make that shading nice and light. Our second inequality, we don't have an x there. All we have is a y. This is something we refreshed on last class. We looked at inequalities that just had y, and we looked at ones that just had x, how we graph them, how we test and shade with them. So if we have y is greater than or equal to 100, we talked last class, and I know most of you would pick out that point right there that I just highlighted in purple. Most of you would tell me, Miss Golly, there's where y is 100. Yep, it's 100 there. That's at the point 0, 100. But there's lots of points that the y is 100. And on this graph, we don't want to do 100. We could, it'd just be really, really close to it. The point 25, 100. The y is 100. Or we could go 50, 100. The y is still 100. That's our only concern, is that the y values for every ordered pair on that line is 100. This one has an equal to, so it's going to be a nice solid line. Just a perfect horizontal line is all that one's going to be. Just a perfect horizontal line. And like we talked last class, if you want to memorize that when there's just a y, that it's going to be a horizontal line, you can. I can't stop you. And then we also talked last class how we test when there's just one variable. You can still test 0, 0. You can still test 0, 0. There's just not an x to put a 0 in for, and that's okay. Don't make one up. Don't dream one up just to put it in. Just put the 0 in for the y. And make your comparison. Don't put another 0 with the 100. We don't want to turn it into 1,000 or turn it into a 0. You can only put the zeros in where there's variables. All right, so is 0 greater than 100? Nope. So we're going to shade that top side of the line where 0, 0 is not. Now the final answer, the final solution area, it's always going to be where your boundary lines are. Your boundary lines are always going to cut off that area or surround that area, but you have to figure out which lines you're using. So we take a look. This section right here, this little triangle piece, it has some shading, but it's only purple. This bottom triangle down here has some shading, but it's only red. This bottom piece down here doesn't have any shading at all. So the piece I'm looking at is going to be this piece that's bordered by the red and then the purple over here. All of this up here has red and purple shading together. All of this here has red and purple shading together. And don't worry about shading it like perfect, because remember guys, this graph keeps going up and up and up and to the right forever and ever and ever. So if the shading's not perfectly inside the boxes, that's okay, because this graph really does keep going. So that's okay if it's not perfectly in there. All right, letter C. We need a solution to this. We wrote some inequalities, we graphed, we have our solution region. Now we need to actually answer the question. Any ordered pair in what is now shaded yellow on my graph will meet the needs of these soccer clubs to raise enough money for their uniforms. Any ordered pair in there. So I'm going to go with, let's see, I'm going to go 200, and you know what, let's go easy. Let's go 200, 200. It's right there. Here's where you have to be very careful. When you change your scale, you have to make sure when you pick out your ordered pair, it's matching. So this isn't 8, 8. This isn't the ordered pair 8, 8. I did go over 8 boxes and I did go up 8 boxes, but each one of those boxes is worth 25. So you have to be careful and make sure that if you change your scale, when you pick out your ordered pair for your solution, that you still stick with that scale. So when we go to write this, we want to say the boys club could sell 200 cards, and the girls club could sell 200 candles. So basically, label your final answer. In this case, we're selling items. How many of each item are they going to sell? Be careful, and this is, again, the labels come in handy. X is the number, Y is the number. So they're not selling $200 worth of cards, they're selling 200 cards. They're not selling $200 of candles, they're selling 200 candles. So be careful with your labels. So again, a couple highlights on this question. Couple highlights. There's no equal to in that top inequality, so we do have a dotted line. Our second inequality only involves one of the variables. It only involves candles, so it only involves Y. I know that's a new idea for us. Third big idea from this problem, why I chose it, the X and Y scales, we had to change them to go by 25 so our graph could actually fit. So then when we go to get our final solution, we have to make sure we stick with that scale and we pick out that ordered pair. So just be careful of those big things on this type of question. And I will do this much for you. The rest of this packet's going to be yours. But let me go back through real quick. Number 3 is going to be similar to question 5. And I know you might be thinking, Miss Golly, why did you do question 5 before 3? Because question 5 had a few more elements to it that I wanted to show you. Question 3 is like 5. Question 4 is like number 5. Question 7 and that's it. So 3, 4, and 7. 3, 4, and 7 are all like number 5. Okay, so what I mean by that, what I mean by being like number 5, they're going to have an inequality like this second one where there's just one variable involved. It might not be Y. So the ones that I had you kind of highlight, those questions, those are all similar to number 5 because one of the inequalities will only involve one of the variables. It might not always be the Y. You have to pay attention to what your variables are representing.